Hello everyone, myself Mayuresh Rao, Assistant Professor, Department of Pharmaceutical Chemistry, Sinhagad Institute of Pharmaceutical Sciences. Today we are going to discuss Birch reduction. So what is Birch reduction? Reduction of aromatic rings by means of alkali metals like sodium or lithium in liquid ammonia in presence of alcohol to give unconjugated dihydroderivatives is known as Birch reduction. The reaction is shown here, that is benzene. It reacts with sodium and liquid ammonia in presence of alcohol to give dihydrobenzene. Now let us understand the mechanism of Birch reduction. Step 1 involves removal of electron from sodium metal into the solvent. Electrons, they get trapped in solvent called as solvated electrons. So sodium metal, it reacts with ammonia to give sodium ion plus electron. In step 2, there is attack of electron which is produced in step 1 on benzene ring to form a radical anion. So the electron which is produced in step 1, it will attack on benzene ring to give radical anion. You can see here there is a radical charge as well as there is a negative charge, so that's why it is called as a radical anion. Step 3 is abstraction of proton from protic solvent such as ethanol to give a radical. So this protic solvent such as ethanol, it will abstract the proton over here and it is going to give us radical anion. Step 4 is attack of radical ion by metal electron to give an ion. So this electron, it is going to attack at this radical position and going to give us radical anion. Step 5 is anionic center which is generated in step 4. It attracts electron deficient hydrogen and reduction of benzene takes place. So this will attract proton and it will give us the final compound, that is 1,4-dihydrobenzene. Advantages of Birch reduction include it can be easily carried out. The reagents which are required for Birch reduction, they are easily available and reasonable in price. It is also useful in development of new compounds. Conjugated double bond can be selectively reduced to non-conjugated ones using Birch reduction, and selective reduction of double bond can be carried out in steroidal drug synthesis. At the same time, there are some disadvantages of Birch reduction, that is, it is not applicable to non-conjugated molecules and ordinary olefins are not affected by this condition. Applications of Birch reduction: 1-naphthol on reduction with sodium and liquid ammonia, it gives 5,8-dihydro-1-naphthol. The reaction is shown below, that is 1-naphthol. It reacts with sodium and liquid ammonia to give 5,8-1-naphthol. Second application is dihydroabietic acid is reduced to abietic acid in presence of powerful reducing system using lithium and ethylamine with a protic solvent like tertiary butanol. The reaction is shown below, that is dihydroabietic acid. It reacts with lithium and ethylamine with protic solvent like tertiary butanol to give us the final compound, that is abietic acid. So thank you for patient listening and subscribe my channel, that is Chem Corona. Like, share and subscribe. Thank you for patiently listening.